Hi, this is Alex from devstories.eu. DeepEval Framework, Episode 1 of 18. Most teams evaluate their newly deployed language models by manually reading a spreadsheet of responses. It is slow, heavily biased, and impossible to scale as an application grows. DeepEval is the open-source evaluation framework that replaces this manual work, functioning effectively as the Pytest for LLMs. Suppose your team is deploying a new generative application. You need to ensure it behaves correctly before pushing it to production. With DeepEval, you write tests exactly the way you write standard Python unit tests. You create a file named testexample.py. Inside that file, you construct a test case. This test case object holds the initial input prompt, the actual output generated by your application, and any expected target answers. You then apply an evaluation metric to this test case. Instead of using a standard equality check to see if variable A perfectly matches variable B, you use a specialized assertion function provided by the framework. You run this file from your command line using the standard Pytest command. The framework executes the tests in parallel, catches the assertions, and reports passes and failures right in your terminal. Here is the key insight. Standard deterministic tests cannot evaluate the quality or accuracy of human language. If a user asks your application for a summary of a document, there are thousands of correct ways to write that summary. Regex patterns and exact string matching are useless here because they cannot interpret semantic meaning. DeepEval handles this massive variability using a concept called LLM as a judge. The framework uses a highly capable generalized language model to evaluate the specific outputs of your own application. The judge model reads your application's output, compares it against the strict criteria of the metric you selected, and calculates a numeric score. More importantly, it outputs a Boolean result indicating if the score meets your predefined threshold, alongside a plain text reason explaining exactly why it gave that score. This means a failed test gives you immediate debugging context. When designing these test cases, you must choose between two distinct modes of evaluation. It is easy to confuse the scope of these modes, so let us draw a clear line. End-to-end evaluation only looks at the initial input and the final output. The entire application is treated as a black box. You provide a prompt, the system gives an answer, and the judge scores that final text. It completely ignores how the application generated the response. Component-level evaluation is a white box approach. Instead of just checking the final answer, this mode traces the specific internal steps your application took to get there. If your system searches a database to retrieve context documents before generating its text, a component-level test evaluates that specific search step. It checks if the retrieved documents were actually relevant to the user's prompt, entirely independent of the final generated response. You test the internal machinery, not just the final product. You can have a system that passes an end-to-end test by giving a correct answer, but fails a component-level test because it pulls that answer from the wrong internal document. Evaluating a language model is no longer a subjective reading exercise. It is a rigid, automated, and repeatable piece of your continuous integration pipeline. Thanks for listening. Happy coding, everyone.